Welcome to Eagles Concept Training Room. In this session, we'll take you through senior secondary mathematics and the topic is calculus. Alright, so if you are watching us for the first time, please click on the subscribe button to get more access to our content. And also like our Facebook page at Eagles Concept Academy. Now, calculus is a very wide topic. Calculus is a very wide topic at different levels. Now, this video has been designed to help you just to tackle on the concepts that will help you handle the questions that come in both paper 1 and paper 2 of your examinations. So the first thing that we are going to do is we are going to show you what differentiation is. Then we are also going to show you how to solve the gradient of a curve at any point. Then you solve equations of a tangent to the curve. Thereafter, we deal with equations of the normal to the curve. Thereafter, we deal with the stationary points. And finally, we deal with integration. So stay tuned as you go through each of these.
Differentiation. So we are looking at differentiation. So now, differentiation is something that is very important. It has got a lot of formulas. Okay, differentiation has got a lot of formulas. But in here, we are going to do a formula that is most relevant to your exams, which is the power rule. Of course, you can differentiate using other methods that you're going to find in your literature and all that. But right about now, we are interested in using the power rule. Okay, so the power rule, for example, if we are given an equation, so we are using the power rule to do the differentiation. So if you are given an equation y is equals to ax to the power n plus let's say plus bx to the power m, then dy by dx, this is how we integrate, then dy by dx will be equal to nax to the power n minus 1 plus this one will be mbx to the power m minus 1. Okay, so this is the power rule. So what are we saying here? What we are saying is you have to get this power, bring it down here, multiply it with this one, then this one here which remains you say minus 1. Then you have integrated, you have differentiated. Then also to this one the same. Then as we do this, as we are introducing, please note that when we are integrating when we are differentiating, when we differentiate a constant number, for example 2, 3, 1 and so on and so forth, this one is always equal to 0. Okay, so when we are trying to differentiate a constant number like that, what we get is a 0. Let's go into the practicals and just see what I'm talking about and how easy it can be. So let's look at the solutions. The first question there, they have said y is equals to 4x to the power 3 plus x plus 1. So if we are to integrate this one, what we are going to say is dy by dx. So this y and this x, the other one, dy by dx is equals to, then this 3 here, it will come in front, then we multiply it with the 4x to the power 3. Now, because this one here, we have brought it down, so on top here, we're just going to say minus, then plus. Okay, so this one now is x. So this x here also has got a power 1, which is silent. So we are going to bring that 1 multiplied by the x, then to the power 1 minus 1. Then, like I said, when we differentiate a constant number like this one, just ignore it because it is 0. So this one can be simplified now. 3 times 4, this one will give us 12. So 12x, then 3 minus 1, this remains squared, plus. Then this one will be 1 times x is x. Then x to the power 1 minus 1 is 0. Then we know that any number to the power 0 is 1. So finally, dy by dx here will be equal to 12x squared plus 1, because any number raised to the power 0 is equals to 1. That's why we are writing 1. So you have differentiated. It is simple as drinking water. Okay, let's go to the second question. This one says y is equals to x to the power 3 minus 3 over 2 x to the power 2. So we still follow the same principle. Dy by dx here will simply be equal to, this 3 comes down here, so 3 multiplied by our x, So that 3, then minus 1, minus this 2 also comes to the front, so it will be 2 multiplied by 3 over 2, then x to the power 2 minus 1. This is what is going to happen. So 3 times x, it will give us 3x, okay? Then 3 minus 1, it will give us 2, minus, then this 2 multiplied by 3 over 2 is just the same as this one and this one, they cancel, then you remain with the 3x. So 2 minus 1 is 1, so we don't write if it's 1 there, we just have to know that it is there. So therefore also here we are saying dy by dx is simply equal to 3x squared minus 3x, and we have differentiated. Okay, last one, y is equals to x to the power 3 plus x squared minus 5x plus 3. So the procedure is the same. There is nothing so tricky about differentiating. Okay, at your level as grade 12s, the kind of differentiating that appears is this straightforward one. So again, the 3 comes down, so dy by dx is equals to, so the 3 will come down, multiplied by the x to the power 3 minus 1, plus the 2 will come down, which will be 2 multiplied by x to the power 2 minus 1, minus, so here we also have a 1, an invisible one, so that 1 will come down, multiplied by 5 to the power 1 minus 1. So here we know this one because we know it is 0. Okay, so this one becomes now 3x squared plus, because 3 minus 1 is that one, 3 times x is that one. So here also, this is just 2x, because 2 times x is 2x, 2 minus 1 is 1, which we don't write. Then this one will be minus. So when you check now here, this one is going to be negative 1 times 5, it will still be negative 5. Then this x to the power 0 is 1. So any number to the power 0 is 1. So we'll just remain with minus 5, and that is our dy by dx. So maybe just to explain a little bit further about this one, what we did was this. This is, we found 1 times negative 5, then times the x to the power 0. That is the way it remained. So we know that 1 times negative 5 is negative 5, then any number to the power 0 is 1, so it became times 1. That's why I said it is just minus 5. So please remember, the power rule is the easiest that appears in your exams. When differentiating, just know that you have to bring down the power in front, you multiply it, then to write it back, you have to subtract minus 1. And that is how we are looking at how to find the gradient of a curve at any point. So now, before we can look at the sample question here, I have an example of a curve, because some of you might be wondering. So a curve, it will look something like this. So now what we are saying is, you can find the gradient here, you can find the gradient there, you can find there, at any point here, you can find the gradient. Now, how do you find the gradient? Remember, these things here have been properly laid down, because for you to know how to do this, you have to know this. So now, differentiation, dy by dx is known as the gradient function. So we are saying dy by dx is known as the gradient function. So it's known as the gradient function. So meaning this dy by dx can be used to find the what? The gradient. So dy by dx, in other words, we are saying dy by dx is equals to gradient m, which can also be y2 minus y1 over x2 minus x1. So that is just the gradient function. So for example, if we have a question here which says deduce the gradient of the curve y is equals to x squared at 2, 4. So this is a point. Now this is x, y. Our main interest is the x. So 2, 4. 2, 4, maybe for instance it can be here. So we want to find the gradient here. Okay, so if we want to find the gradient here, now if the question just came without the curve, because this curve is just imaginary. So what we are going to do, the first thing here is, we are going to say, we first of all have to find dy by dx. So y is equals to x squared, dy by dx will simply be equal to, you bring down the 2 here, multiply it with x, so it will just remain 2x, because 2 minus 1, it will still be 1. So this is our gradient function. Okay, so if this is our gradient function, then we know for truth that dy by dx is equals to the gradient, which is equals to, in this case, 2x. And we know that 2x here, they've given us a coordinate, because they're saying at 2, 4. So we look for x. So this x here is what? Is 2. So it will just be 2 multiplied by 2. And our gradient in this case is 4. So determining the gradient of a curve at any point is as simple as that. Step number 1, you have to make the gradient function, which is dy by dx. Then step number 2, you have to substitute the value of x into the gradient function, and your gradient is found. So it is as simple as that. And for our practice, our exercise there, let us try this question. For the curve y is equals to x3, find the gradient function. Then B, find the gradient at the point 2, 8, which is exactly what has been done in the example. I believe this one will be a straight and forward thing. So let me see you submit the work in the shortest possible. We're going to look at two concepts: the equation of the tangent to a curve, and also the equation of the normal to a curve. So by the end of this lesson, you understand these two things, and they usually come in the exam. Okay, so to begin with, before we can look at the sample questions that are there, we are briefly going to explain what a tangent is. So we'll start with the equation of a tangent. So now, a tangent is simply a line that only touches one point of a curve. So for example, we can have a tangent. Maybe they say there is a point that has been drawn here. So as we draw the tangent here, we should make sure that that line should only touch one point of the graph. So that line there, which is only touching one point of the graph, then this one is a correct tangent. So it can be here, it can be here, as long as when you draw the line, it touches one point of the graph. So this is what we call the tangent. Okay? Then also, we are also going to deal with the normal. So for the normal, this is a line that is drawn perpendicular to the tangent. So when we draw a line here, which will be perpendicular to the tangent, what I mean by perpendicular is when we draw it like this, and then it will form a 90-degree angle. So this one is what we are going to call the normal. Okay, so a tangent is the line that touches only one point of the graph, and the normal is the line that is perpendicular to the tangent. So now, the relationship between these two is that when you multiply, so the tangent, when you find the gradient of this tangent, it will be called m1. Then the gradient of the normal will be called the m2. So the relationship between these two lines is that when you multiply the gradient of the tangent and the gradient of the normal, the product will be -1. So what I'm saying is m1 multiplied by m2, the answer should be -1. So that is the relationship between the normal and the tangent. Okay, so having that knowledge, let's now see how we can find the equation of the tangent. So we'll start with the tangent, we'll call it question 1. So this one here, sample 1, and this one will be number 2. So we'll start with our first one there. So solution, please follow the steps. They've been summarized such that you can be successful in your examinations without difficulties. Okay, so now find the equation of a tangent to the curve, and they've given us this curve here. So the first at the point x. So step number 1. Now let's follow the steps properly. So step number 1, you have to find y. Find the value of y. So step 1, we are finding the value of y. So just substitute, because they've said x is what is equals to 1. So y is equals to 4x to the power 3 plus, that is x squared. So x squared plus 4x minus 3. So we just substitute. That is step 1. So y will be equal to, that is 1 squared plus 4 multiplied by 1 minus 3. So this is 1 plus 4 minus 3. This one will give us 5 minus 3, and the value here will be 2. That is step 1. You have found. Then step 2. Step 2. Now you find the gradient. Find the gradient. Okay? So step 2, you are finding the gradient. Remember the gradient function? So to find the gradient, we first of all have to find dy by dx of this one. So dy by dx will simply be equal to, the 2 comes down here, we are going to have 2x plus, then this one here, it will be minus 1. This one will just be 1, so it will be plus 4. Remember what we learned? Because this is 1, we bring it down. 1 times 4 is 4. Then this one will remain to the power 0. Anything to the power 0 is 1. So that is how come we're finding 4. Then also remember the derivative of a constant number is 0. So we just ignore it. So the dy by dx is this one. Then we know that dy by dx is equals to gradient. So for us to find the gradient m here, we are simply going to now substitute. Okay? We substitute. We put 2, we put 1 there, plus 4. So this one will simply be equal to 2 plus 4. And our gradient here will be 6. Okay, so we proceed. Now that we have our gradient, and remember we said gradient of the tangent is known as the m1. So we have found our m1. Now we can find the equation now. Step 3, which is the final step here, we now find the equation. So we find the equation by substituting. Okay, find the equation by substituting. Okay, so we are saying by substituting the found values into the equation. So into the equation, m is equals to y2 minus y1 over x2 minus x1. You remember this one? So we continue. Our gradient now is 6, so it will be 6 is equals to our y2 we don't know. We only have one set of coordinates because after we found the value of y2 here, we had a set of coordinates now here, which would be 1, 2. So this is the reason why we are finding this one. So we have this set, which is the x1, y1, but y2 and x2 we don't have. So y minus, so that one is the minus 2 over 1 over x minus 1. Then there we can cross multiply. So this is 1 multiplying with y minus 2, which is equals to 6 multiplying with x minus 1. So this is y minus 2 is equals to 6x minus 6. Then this one here will be y is equals to 6x minus 6 plus 2, because this one crosses. So y will be equal to 6x minus 4. And we have found the equation. So the equation, always y has to be the subject of the formula. Okay, so as we are still doing this one, let's look at also the steps for determining the gradient of, for determining the equation of the normal. So determining the equation of the normal, also it follows almost the same steps, except that this one, it has been simplified into 4 steps so that you can easily master them and apply them appropriately. Okay, so also here, step 1, when you are determining the equation of the normal, step 1 here, it's one and the same thing like we did in the previous. So step 1, we are simply going to also find the value of y. So find y. So we are going to write y is equals to 4x to the power 3 plus x plus 1. Okay, then this one will be y is equals to 4. We put our value, which is negative 1 to the power 3 plus, so negative 1 plus 1. Okay, so y is equals to, so this negative 1 to the power 3, it is still negative 1 and negative 1. So times this 4, it will still be negative 4. Okay, then this one and this one will be negative 1 plus 1. So it is as good as these are cancelling each other. So y is equals to negative 4. This implies that we now have the coordinates, which is negative 1, negative 4. Okay, so we proceed to step 2. So proceeding to step 2 now here is now where we are saying we want to find the gradient. So to find the gradient now, listen, we said m1 is the gradient for the tangent, but here what we want is for the normal. And so to find the gradient of the normal, you first of all have to find the gradient of the tangent. Then you use that relationship which we discussed. So the first thing here, we find the gradient of the tangent. So find m for the tangent. So find the m1, which is for the tangent. So also we say dy by dx is equals to m, which is equals to, so that equation there we are going to go straight forward. The 3 comes down. We are going to have 12x squared plus, so this is the 1, and it ends there, because 1 minus 1 will give us 0. Anything to the power 0 is 1. So that is to find the gradient, we put the value of x, so it will be 12 multiplied by negative 1 squared plus 1, so it will be 12 plus 1, which is equals to 13. Okay, so now after we find this one, we can proceed and also say maybe step 3, we also find now, we find m2. So finding m2, we are simply going to say m1, m2 is equals to negative 1, because that is the relationship between the two. So this one will be 13 m2 is equals to negative 1. Then we know that m2 here will be equal to, because we divide by 13, we also divide by 13, will be equal to negative 1 over 13. So that is our m2. Okay, so we proceed now. We continue to the next step. Okay, so in the next step, we are going to now substitute what we have found. Okay, so this is step 2. So we go to step 3. So in step 3, now we have the coordinates, we have our gradient. So the next thing that we have now is to substitute into the equation like we did before. So the equation is m is equals to y2 minus y1 over x2 minus x1. So substituting into this one now, we are going to say, okay, we have the gradient, which is negative 1 over 13 being equal to, okay, being equal to y2 we don't have, so it will remain y, minus, then y1, we check our y1, which is negative 4, okay, over x we don't have, then we have the xy, which is negative 1, so that's what we have. So this one will be negative 1 over 13 being equal to y plus 4 over this, and that is plus, so over x plus 1. Okay, then here it means we cross multiply, so we are multiplying, this is 13 multiplying with y plus 4, which should be equal to negative 1 multiplying with x plus 1. So this one we have 13y, then plus 53, okay, yeah, so plus 50, so 13 times 4, let's do this one, 13 times 4, this is 12, okay, we have 52, so this is 52, which is equals to negative x, negative 1. So we group the like terms because y has to be on its own, so it will be 13y is equals to negative x, negative 1, negative 52. So this one will be 13y is equals to negative x, negative 53. So divided by 13, divided by 13, divided by 13. This one and that one goes. So here we have y is equals to negative 1 over 13x, then minus, so this one into that one, it goes there 4 times, leaving a remainder 1 over 13. And this is how we determine the gradient of the normal. So quickly for a summary, I'm sure you would have noticed something. It is very important that we know the relationship m1 times m2 will give us negative 1, because it is going to be used all the time when you want to find the gradient of the normal. So step 1, find the gradient of the what? After you find the points here, then you have to find the gradient of the tangent. After you find and use the gradient of the tangent to find the gradient of the normal, which is m2. Then having found that, you just have to substitute into this equation and you are done. So that is how we find the equation of the tangent. Now today, our main focus will be on the stationary points, which are also called the turning point. So now, what is this point? So the definition of a stationary point or a turning point is simply that this is a point where the gradient of the curve is 0. So a stationary point, which is also called a turning point, this is simply a point where dy by dx is equals to 0. Okay, so now just giving a summary of it all, we have 3 types of turning points. So even when you are drawing the graphs, you are going to obtain 3 types of curves. So we have a curve which is called a maximum. So a maximum right here where the graph bends is where we find the maximum value, which is a y value. Okay, then also we have another type of a stationary point, which is a minimum. So at the bottom right here we have a minimum value. Then the third type is an inflection. So for an inflection, this is how it looks like. It can face in any direction, but it has a certain point where it is inflecting, okay? So these are the three types of stationary points. Now, why are we learning about stationary points? We are going to see how questions in your exam can come. So for example, the simplest question of them can come, find the turning point for the equation y is equals to 3x squared plus 6x plus 1. So we want to find the turning point for this curve. Now this is an equation of the curve. So we want to find the turning point. Now by definition, we know that dy by dx is equals to 0. So a turning point is the point where dy by dx is equals to 0. So what you are going to do is step number 1, so solution number 1. So the first step that you are going to do here is you are going to differentiate the given equation. So you differentiate. That is the first thing that you are going to do. So differentiating, now we have our equation, which is y is equals to 3x squared plus 6x plus 1. So differentiating this one, we are going to say dy by dx is equals to 0, which is equals to this one comes down here times 3, it will be 6x plus 6, because a 1 comes there, it will still be 6x. We subtract 1 minus 1 is 0. Any number to the power 0 is 1. So 6 times 1 still gives us 6. Then the derivative of the constant number is 0, so we ignore it. So now we can solve this one because we have an equation 6x plus 6 is equals to 0. So meaning 6x is equals to negative 6 when it goes that side. So you divide by 6, you also divide by 6. You cancel that one, cancel that one, cancel that one. You have now x being equal to negative 1. So now you have found the value of x, okay? But the question is saying find the turning point for this graph. Now the turning point has to be a coordinate which should be in the form x comma y, okay? So now for such questions also, they actually specify. So this turning point, find the turning point for this one. So having found the value of x, the next thing you are going to do is you are now going to substitute into this one now, the same equation. So step number 2, step 2 here, you do a substitute. So substitution into the given equation. What are you substituting? The value of x which we have found. So you are going to say y is equals to 3x squared plus 6x plus 1. So this one here, it will be 3, open brackets there. You put your negative 1 squared plus 6, you put your negative 1 plus 1. So this one here, it is 3 because 1 squared, negative 1 squared is 1 times 3 is 3 plus. So this plus, now before you write plus, there is plus and negative giving us negative 6 plus 1. So 3 minus 6 is definitely negative 3 plus 1 here, our answer will actually be equal to negative 2. So having found this one, we are now going to say, okay, we can now find our turning point or the stationary point to be equal to, since the x is negative 1, so it will be negative 1 comma negative 2. And we have found our turning point. Okay, let's see now how best we can also see how it comes. So in paper 1, mostly paper 1 of your exams, there is always such a question like this one, which doesn't miss in your exam. It always appears. So let's have a feel of how it can be applied in an exam situation. Okay, so using the same knowledge, an extract of the question we have been given here reads, find the coordinates. So the diagram below shows a sketch of the graph. There is a sketch of our graph. Okay, so for the sketch of our graph now, they are saying we should find the coordinates of E and G. So this is basic thinking. Look at how this graph is cutting the x-axis. So definitely here, this point here, the point that is here, that is the first thing. The point that is here, you can really tell that this is E comma 0 because the y value here, right here, is 0. Then also here, you can also tell the same thing. This is G comma 0. So the point is 0. So now, how do I find the E value here? Because E value is X and the G value is X. But in both scenarios here, as you can see, the value of Y is 0. And we have been given an equation there. So since we have been given an equation, we can use this same equation because we know that Y is 0 in both instances. So what we are simply saying is where there is Y, we put 0. So we are going to have now an equation 2 plus X minus x squared is equals to 0. So the fact that the highest power is 2 there, we know that this is a quadratic. So we are going to say A is equals to, okay, that is -1 there. Then our B is equals to 1. Then our C is equals to 2. So we find our product, which is A times C. So our product will be -2. Then we are going to find our factors. Two factors such that when we add them, they will be equal to 1. But when we multiply, they will still give us back the -2. So what we are going to do here is very simple. We are going to check if you get -2, if you get 2 minus 1 here, you are going to find 1. So this one we can rewrite. So we are saying we have 2 and -1. So these are the factors, because when you say 2 minus 1, it will give us 1. But when you say 2 multiplied by -1, it will give us -2. Okay, we all have knowledge on these things. So we rewrite this one. It means these, they will replace this guy here. So instead, we're going to write 2 plus 2x minus x squared. Okay, so these two have replaced that one. Then we categorize these like that because it's factorization. So what is common in here is 2 open brackets. We remain with 1 plus x. Then the negative here, what is common there is x. Then here I'll remain with 1. Negative and negatives give me plus. So I remain with x there. Then this and this are the same, which is enough evidence that I'm doing the correct thing. So finally, the factorized equation now here will be 2 minus x, and I get one of these since they are the same, which will be x plus 1. So this is equal to 0. Then the next thing that you're going to do is you solve this one. So 2 minus x is equals to 0. So this one will be negative x is equals to 0 minus 2 because it goes there. So multiply by a -1, it will be x is equals to, also here by a -1, x is equals to 2. So you have found your value there, x is equals to 2. Then you also solve this one, which is x plus 1 is equals to 0. So x will be equal to 0 minus 1. So x is equals to -1. Now, you have found two values of x. The other one is -1. The other one is 2, which makes sense. This side of the x-axis is positive. This side is negative. So definitely our E now here, it will be, because it's a negative side, it will be -1, 0. And this other one will be 2, 0. And you have found the coordinates. X is equals to 0. So we are simply going to say, okay, dy by dx is equals to 0, okay? Which is equals to, in this case now, so dy by dx is equals to 0. So the first thing that we are going to do now is we are going to differentiate this equation here. So dy by dx of this equation here, this is a constant, it will be 0, so we ignore it. This one is just x, so it will just be 1 minus 2x. That is dy by dx of this one. Then they are telling us dy by dx should be equal to 0 because it is turning. So now we have our equation there. So this one will be -2x is equals to 0. Then this crosses that side, it will be -1. So divided by -2, divided by -2. This and that goes, this and that goes. So our x is equals to half. Okay, so that is how you find the value. Now, before calculus was introduced into the syllabus, there was some crux method that we were using, but it works because there was no calculus in syllabus D. So what you can do is, because you know that between this one and this one, this graph is going to turn right at the line of symmetry. So you can easily say you add these two and this one here, and then you divide it by 2. So you find the average of these points. So 2 plus this one here, then divided by 2. I'm sure you will still find the same value. But maximum value y, which is here, we have found our x. So we substitute into the equation directly. Y is equals to 2 plus x minus x squared. So this one will be equal to, so 2 plus our x here, we know it's half, then minus, this is half squared. Okay, so we solve this one, we are going to have, this is as good as 2 plus 1 over 2, so this is over 1, then plus, so squared, this is 1 over 4, because 1 squared is 1, then 2 squared is 4. So there we can sort it out. Okay, we sort it out. Our marker seems to be failing due to gravity. Okay, but it will work. So we have 4, then 1 into 4 is 4. So 4 times 2, this one is 8, plus 2 into 4 is 2, times 1 is 2, plus 4 into 4 is 1, times 1 is 1. So this one will be equal to 8 plus 2, that is 10, 10 plus 1, that is 11, so 11 over 4. And this one is equals to 2 remainder 3 over 4. And we have found our answer. And this is how we determine
Differentiation.
the value.
For example, if we have dy by dx is equals to ax squared, then y will be equal to ax n plus 1 divided by n plus 1. So there are two types of integrals. We have got what we call definite and indefinite integrals. Then integration can also be used to find area under a cubic graph. Let's look at these examples. Under indefinite integrals, this is how we do it. Remember, for differentiation, we are subtracting 1. So now, it's like we are now returning it back. That's why this symbol here, it means back to differentiation. All right, so the simple procedure that you have to do here is very simple. You are simply going to say 5x to the power 2, then you have to add plus 1. Then what you do to that one, you also do down. So even down, it will be 2 plus 1 as well. So minus 4x. So this 4x is the same as it is powered to 1. There's an invisible one. So we're just going to add plus 1. Then over 1 plus 1. Then this one will be plus. Now remember, this number here, for it to remain like that, we have just removed an x. Okay, like what we say, you just ignore the x. So we have to put back the x. That is a simple rule. So to a constant number when integrating, just add an x. Right? When integrating, just add x or y, depending on what letter is there. That's what you add here to a constant number. Then remember, there was a c that gives 0 and we forget, so we write as c. Okay, so this one will now be 5x to the power 3, okay, then over 3 minus, so this one now becomes 4x squared, so this is 4x squared over 1 plus 1 will give us 2 plus 5x plus c. So we have that one, then we can reduce it. So this one will remain the way it is, 5 over 3 x to the power 3. Then this one will be minus 2 in here, 1, 2 in here, 2. So minus 2x squared plus 5x plus what? Plus c. So we have successfully what? Integrated. Okay, this is what integration is all about. Now, you can prove your answer. Let's do a quick proving of the answer here. What we can do is we can try to differentiate. Let's try to differentiate the same one. So if we differentiate this one, then dy, okay, dy by dx will simply be equal to, so this 3 will come down here, so it will be 3 multiplied by 5 over 3. So this is x to the power 3, then here we have to subtract 1. Then this one will be minus, this 2 will come down, so it will be 2 multiplied by 2, then x to the power 2, we subtract 1, okay, then plus 5x, okay, so this 5x is just the same as the 1 here, which will come in front, 1 times 5 there, then 1 minus 1, then plus a constant c, which we cannot find, okay, so this 3 and that 3 will cancel there, so we're going to have 5x what squared, because 3 minus 1 is a 2 here, then minus 2 times 2, that is 4. then 2 minus 1 is 1. So this one will just remain what? X. Then plus, so this one here, because it's 1 minus 1, it is 0. Anything to the power 0 is 1. So we'll just remain with 5. And we have gone back to the question. So meaning what we have done here is the correct thing. So that is how you integrate. And these are known as indefinite integrals because we are not evaluating. Okay, so indefinite integrals we don't evaluate. Okay, let's look at the second example. We are still under indefinite integrals. So we look at the second example. So in the second example here, the first thing that we have to do is you have to remember this number here, this number, it simply means what? Negative. So we are dealing with powers. So this one can also be written as what? This number can also be written as okay, so the x, this one is equals to, this is the same as negative 1. Okay, so this one is the same as negative 1. So if that one is the same as negative 1, then it is going to be this one here. If we say this one, actually, let's add the 2 here. There's a 2 that we forgot. So this is 1 over x squared. So we can change this one. Let's solve it from down here. So this one will simply be equal to x like this to the power negative 2. That's what it means. So we can change this one. So if I write a number like 1 over b, so I can change it and write it as b to the power negative 1. So I'm converting from this format to this format. Now, since we are using the power rule, I have to remove it from this format into this format. That is what I've done there. Okay, so if I'm integrating, then I'm just going to add plus 1. This one here, it simply means integrate. Then over what I do on top, even this also I do negative 2 plus what? Plus 1. Then this one will simply be equal to negative 2 plus 1 is negative 1. So this one will be x to the power negative 1, then over negative 1. So this one will be the same as negative x, then negative 1. So this one will definitely go back, okay? So that becomes negative x, negative 1. Then always remember, don't forget the plus c, okay? So plus c should always follow, even there, plus c. Then I should take it back now to this format in which it was. So now I'm going to have, when that happens, what I'm going to have is, I'm going to have now 1 over x, okay? So 1 over x, okay? So 1 over x, and this x is negative. This one here, I've changed it, plus what? Plus c. So this is what I'm going to have when I integrate. All right, so let's integrate this one as well. So remember, the rule says that to a constant, you simply add x. So this one will simply be 2x, then minus, so this is 3x. This is the same as its powered to 1. So I'm just going to add another one there, then over 1 plus 1. So this becomes 2x minus 3x squared. So 3x squared over 2. And I have integrated. So this one can even remain just where it is. And always, please don't forget plus c. It's very important. So plus c. Always, we don't forget, whatever you are doing, you always have to write plus c at the end during integration. All right, let's look at the definite integrals now, how to handle definite integrals. So the first thing that you do when you're handling definite integrals is you have to integrate like you have been taught. Okay, so this one will just be 3x to the power 2 plus 1. And this one will be also over 2 plus what? Plus 1. Then minus, this is the same as 2x here to the power 1 plus 1. Then this is over 1 plus 1. So please, that is the procedure. You just add plus 1 to the power, you add plus 1. In differentiation, we subtract minus 1. But in here, since we are taking it back, this one means back to differentiating. So we are supposed to be adding plus 1. Then plus c. So to the constant here, we just add this. So this is 1x, but there's no 1x. So we're just going to write it. So plus c. So this is what you're going to write. So this becomes now, this is 3x to the power 3 here, then over 3, then this is minus 2 x squared over 2 plus x, then plus c. This is what it is becoming. So this and that, it leaves us with the x to the power 3 minus this and that, it leaves us with the x squared plus x plus c. Okay, now that you have done that, what you're going to do is very simple. You start with the top one here. Okay, you start with what? The top one. Okay, so plus c. So we have also here x is x to the power 3 minus x squared plus x. Then what you do, since now here these are definite integrals, this is where you have to evaluate and find the actual answer. So what you're going to do is here, what you're going to do is this. In the first one here, you put in brackets. So where there is x, you are putting 2. So you're going to say 2 to the power 3, then minus 2 to the power 2, then plus 2 plus c. You close the brackets, then you say minus. Then on the other one, since you had used this one, now you're going to use 1. So this one is going to be 1 to the power 3, then minus 1 to the power 2, then plus 1 plus c, and you continue sorting it out. So this is it. 2 to the power 3 is 8, so this is 8 minus 4, so this is 4. So this is more like 8 minus 4 plus 2 plus c. Okay, and this one is giving us 8 minus 4 is 4, 4 plus 2 is 6, so we have 6c plus what? Plus c. So you close these brackets. Then here also this is it minus. Then here 1 to the power 3 minus 1 to the power 2. This one will just simply cancel. Then we have 1 plus c. So in here we have 1 plus what? Plus c. So we work out this one. We are going to have something like 6 minus 1. So we're going to have 6 minus 1. Then this c here. Then minus c plus c. So these will just cancel automatically here. Then we remain with 6 minus 1, which is equals to what? To 5. So this is what definite integrals are. So let me conclude on the definite integrals. The first step is you are supposed to do what? To integrate normally. So we've integrated normally here. Then step 2, you have to write both. First, you have to substitute 2 into the integral. Okay. Then the answer that you find, then on this other step, you have to integrate with the bottom number here. So when you subtract the two values that you have found, then you integrate it like we have done here. So if I wanted, I would have just substituted 2 into this one. I find the answer as 6. Then I also substitute into this one. I find the answer as 1. Then I just subtract the 2. I'll still find what? 5. So this is the procedure on how you do what? You integrate. So please, step 1, integrate. After integrating, you substitute with 2. Then you also substitute with 1. Then you subtract the 2 answers that you're going to find. All right, so integration can also be used for finding area under the cubic graph. So let's look at this example, which says find the area bound by the x-axis. X is equals to 2, x is equals to 4, and the curve y is equals to x to the power 3 plus x. So to begin with, when you're finding area here, you're going to say area is simply equal to. So you're going to draw this this symbol here. Then this value here, you put the values of x. So you start with the value of x, which is big, is the one that you put on top. Then the value of x that is small, that is the one you put down here. Then in here, you put this equation here, which is x to the power 3 plus what? Plus x. And you close, you even say dx. Then you begin to solve it now. So here, this is the definite integral now. Then after finding the definite integral, then you are going to do what? To integrate it. So this one will just be x to the power 3 plus what? Plus 1. Then plus c. This is x more like to the power 1 plus c 1. Then plus c. And don't forget what you do on top, you do at the bottom. So this one will be 3 plus c 1. And this one will be over 1 plus c 1. Okay. So this one will be x, this one will be x to the power 4, then over 4, then plus x squared over 2 plus C. So like I said, the next thing that you have to do is now you have to substitute with a 4 here. So this one will be 4 to the power 4, then over 4, then plus C. This one will be 4 to the power 2 over 2, then plus what? Plus C. Okay, so that is what we're going to do. Okay, that is what we're going to do. So this one will be 206 over 4. So we simplify. This one will be 206 over 4, then plus C. 4 to the power 2, that is 16 over what? Over 2, then plus C. C. Okay, so this one, work it out. So 204 divided by 4 plus 16 over 2. This one will definitely give us 72 here, then plus C. So we close this one up. Then we do the same also where we say we substitute this one to this integral here, this integral which is here. Okay, this integral that is here, we also substitute is in 2. So we're going to have something like 2 to the power 4 over 4, then plus 2 to the power 2, okay, over 2 plus what? Plus C. So we close this one. Then we evaluate this one. So 2 to the power 4 is obviously 16. So 2 to the power 4 is obviously what? 16. And when we add this one, 2 to the power 4, 16. So this is 4. This one gives me 4 plus, this is 4 divided by 2. This one gives me 2 plus C. So I have something like a 6 plus C. So if I bring these two closer together, I'll just subtract. So this I'll just subtract 72 minus 6, and I find the answer. So this 72 and minus 6, because when I say plus C minus this C, these guys, they've just cancelled. So I'll just subtract 72. Okay, I'll just subtract 72 minus 6, which will give me 66 what? 66 units squared. And I found my area. Now, where are you going to apply this thing? In your mathematics paper 2, there is that part for cubic graphs. After you draw, they tell you determine the area bound by the curve, the line, shanshan, and all those things. This is one of the methods that you can use. So to find the area bound by the curve, just interpret this one. So you write the integral, this equation you are given, you put it inside. Then the bigger number here, the bigger value of x, you put it on top. The smaller value of x, you put it at the bottom. Then you substitute. Then you are going to find your answers. All right. Thank you so much for listening to this episode. Check me out as I'll be also explaining on the type of graphs that come in paper 1, and they can use calculus to answer them. And trust me, from 2016 to date, that type of graph always comes where you're supposed to find the coordinates and all that. You can apply calculus there. So I'll be explaining on how to do that one using calculus as well as other methods. Thank you so much. Please share and subscribe.